Hello everyone, this is another video from Easy Electric series, and today we want to learn how you could use the 4 to 20 milliamp analog input to control the speed of the motor. In other words, speed the frequency of a VFD. So this is very similar with the previous video, which we talk about the analog input 0 to 10 volt. So here the difference is, instead of using the voltage 0 to 10 volt to control the speed of the motor, you use technically the current between 4 to 20 milliamp to control the speed of your motor. 4 is for a zero give should be give you a zero frequency, and 20 milliamp should be give the higher frequency that already give to your VFD. For my case is a 60 hertz. So that means if I give here 40 to 20, I should be able to increase from 0 to 60 hertz. So first thing first, wiring. So this is a wiring. So you use the terminal 15 current to the variable current source. So you will see how you could use the lab power supply to do that. I actually show that later on. So anyway, if you have you need actually the current source that able to provide you the 4 to 20 milliamp, and you could change that range with the knob that you have. And you should also connect the 14 to the negative of your source. So if you compare with the voltage is 0 to 10 is terminal 13, and the current technically is terminal 15. So also we are learning about one parameter to you could actually somehow reverse that. So that means instead of increase the frequency when you move to down 4 to 20, you could reverse that and somehow get the minimum frequency at 20 and get the maximum on 4. For doing that, technically you need actually one of the digital inputs. Let's do, for this case, we consider digital input 5. You see the wiring, one side of the switch is 24 volt, the other side terminal 5. Whenever you turn on, technically you deliver 24 volt to the input 05. So that means if I summarize what we want to do, we want to actually give a current to terminal 15 between 4 to 20 milliamp and able to control the speed. In the first case, we are going to, for a 4 milliamp, whenever we give, it's actually give us minimum frequency. 20 milliamp will be actually the higher frequency. After we turn on this switch, that should be reversed. That means whenever you are on 4 milliamp, we get minimum frequency, and in the 4 we have maximum frequency, and in 20 we have minimum. Whenever we close this switch, somehow we reverse that. So parameter that we are using is A51, that we are going to talk later on about that. So what we need to check before actually running that for the programming. So the first thing is P38. So as you see, P38, in previous video we used 20, which gives you control the speed with the analog input 0 to 10. Here you should change that to the 3. So we should change that to 8, which is telling we are controlling the speed with the current input 4 to 20 milliamp. This is the first thing we should do. And the second thing, as I mentioned, is a parameter A051. So if you want to reverse that, so that means the 4 milliamp give you a max and 20 milliamp give you minimum, you should come actually to A051 and also change that to 26. Okay. So let's go to the training side, wiring that, and see how it works. Okay, let's take a look to the wiring. So the first thing is the source, the current source. Here actually I have my current source. I able to actually adjust the current. So how they connected, the positive of that actually connect to the port 15. So the positive of that connect to the port 15 and the negative connected to the analog common, which is 14. So this one actually is 14. Just for wiring, and make sure we are using this as a current source right now, and I'm able to somehow adjust the current with this knob that I have here. So second thing that we are going to do, I actually give a small switch. I connect this switch that I have, one side to the 24 volt, the other side of that I connect it to the terminal 5. You will see in few minutes why we did that. So that means just port 14, 15 to the current source, and port 15 just connect to the one of the switch, which one side is 24 volt. Whenever I close that switch, I deliver 24 volt to the port 5. So as I mentioned, we will see that later on. So, which is why we did that. So let's see. So the idea is just we giving the current 4 milliamp to 20 milliamp, able to run this motor between the 0 frequency to the max frequency, which for my case is 60 hertz. So let's do, before I actually start to run that, let's just make sure we have a right parameters there. So, and we need to take a look to the parameters. So let's see which parameters we need to actually check. So the first parameter is P38. So let's check P38. So this is P that to go up is 38. So that should be actually on 3, which says 4 to 20 milliamp input. So before that was on the 2 for 0 to 10 volt input. We want to actually control the speed right now with 4 to 20 milliamp. That's what we should put the P38 to number 3. I think that's all about the programming. So let's just go to the down and let's run our motor. So before that, let's adjust this to the minimum speed, which should be 4 milliamp, right? So I'm actually coming here and decrease that to, yeah, the 4 milliamp should be 0.004. So right now I adjusted on 4 milliamp. So yeah, it's actually moved to the 4. Let's do that. Yeah, it's actually is 4. So now let's run the motor. So what we expect, it should be on minimum frequency, right? So see, it is actually 0.004 or 4 milliamp. It's almost around 0. So what you expect? You expect to increase that and the frequency go up and motor run faster, right? So this is what we need to do. Let's keep have, maybe if we could have all 3 in the same, which is difficult. Let's just have these 2 frequency and this current in the same frame. So see, now increase to the 5, frequency go up, go to the 6, frequency go up, 7, 8, 9. And what should be the max? Maximum should be on 20 milliamp, right? So that means in 20 milliamp, it should be around 60 hertz, which is my max frequency. So as you see now, it's around 20 milliamp, and I got actually 60. Motor actually is in the high speed, and if you can still decrease that. Yeah, let's see, I'm going to decrease that. As you see, it's actually decreased the speed or the frequency. You could easily control the frequency between 0 to max with the current 4 milli to 2 milliamp. So how about this switch that we connected to the port 5? I explained that. So see what's happened so far. Let I stop this. So what's happened so far, I actually able to control with 4 milliamp to 20 milliamp the speed of the motor. So whenever I increase that, the speed go up. Whenever I decrease that, speed goes down. So that means around 4 milliamp should be a minimum speed. At the 20 milliamp, it's maximum. So if you want to do the reverse that, so that means in 20 milliamp you have zero speed, and in the 4 milliamp you have max, somehow reverse of what we saw so far. You just turn on the switch which connected to terminal 5. But before to do that, we should actually check one parameter here and somehow adjust the parameter which is A51. So for doing that, I'm coming here, I choose the A51, which is the correct, I say enter. So right now is on the 4, it should be on 26 for that's happened. So that means it should be go 26, I say enter. So that means with changing the A51 to 26, it is an analog invert. So technically it should be opposite, right? So that means the 20 milliamp should be give me a 0 and 4 should be max. So let's see that. Let's come back here and let's adjust this to the, maybe go all the way down and adjust these around the 4. So that means now 4 should be give me a max. Let's see it happen or not. So see, it is on the 4 milliamp. So, okay, what I should do, I should turn this on. I forget to turn that on. I turn that on. You see speed is goes up and it is on the reverse direction, right? So see, I have 0 around 0.4. It actually give me around my max frequency that I have. It should be actually 60. So now if I technically increase that, the speed should be decreased, right? So see, I come in here, go all the way down. It goes down and probably around 20 milliamp almost should be around the 0. Now I'm on the 2 milliamp and as you see my motor is stopped. So this is actually how you could use the A51 and the terminal 5 to inverse or reverse that direction. So that means 4 give you a max and 20 give you a minimum frequency.
Two previous video we talk about the VFD analog inputs and we learn how with voltage between 0 10 and the current between 4 milliamp to 20 milliamp, how we could control the speed of the motor. So here I have a example that shows why it is important and how we use that in a real case in our, especially on the building. So here you suppose you have a building, you have actually a pump which is pumping the water. So for sure, whenever you have too many people use the water in the building, so the pressure in the pipe actually goes down. And whenever you have less people use the water, you have a good pressure there. And you have these motor that technically continuously pump the water that all the time you have acceptable pressure on your system. So uh, if you don't have a VFD, so technically you just adjust these pump. So it should be just constantly with the fixed speed. It should be just pump the water anytime, no matter you have less pressure or pressure is good, right? So for sure it's actually used a lot of energy. But whenever you have a VFD and the sensor, technically you have these pressure sensor which is sense the pressure, and for sure whenever it sees the pressure is down, it should be actually send the signal and somehow increase the speed of these motor pump, right? So whenever actually pressure is good, so then it should be actually decrease the speed of the motor. That's what we want to do, right? We don't want to, whenever pressure is good, it's still motor actually pump the water because you have enough pressure there. So which is this actually save a lot of the energy. So if you take a look here, so you see the sensors, these 0 to 10, 4 to 20 milliamp is a standard for a sensors. So that means if you take a look to the industrial sensor, usually they convert whatever they are measuring to the electric signal. That electric signal is 0 to 10 volt, or it is 4 to 20 milliamp current. That's what you have, that these two analog input in the VFD, because that's the sensor standards too. So for this case, for convert pressure to signals, for sure, whenever the pressure is low, so this signal should be increased. It could be a voltage or current. So technically, this sensor increase the current or voltage. Whenever you increase current or voltage through the analog input in VFD, you increase the speed of this pump, and it pumping actually faster, which is it's supposed to be, right? Whenever you have low pressure, the pump should be actually be faster. Whenever you have a high pressure, the sensor actually sense that, and then whenever you have enough pressure, technically you don't need to actually pump too much. So that's why these sensor, whenever the pressure is high, to decrease the signal. So that means the signal is actually go down voltage or current. So then in the same way, the VFD frequency go down, and technically this pump actually decrease the speed and actually pump slowly. So that's what you see, the main application of that. And even you could actually have one target for that, which is bring the PID controller topic in. So if you say, okay, my target is I have a specific pressure here, I won't have a target. So then you need actually the PID controller that somehow control these motor that all the time keep that in the certain pressure. So this actually give you a better idea why we have that analog inputs and why we are able to control that with the voltage 0 to 10 or 4 to 20 milliamp. Also, you could consider this. You could actually connect this to the PLC outputs. So in the PLC, you could have a PID controller. So as I mentioned, put just a certain pressure target, and PID controller able to control that target, let to see any pressure number that all the time you have that certain pressure on your pipes. So I hope it gives you a better idea what's really application of the VFD and these analog inputs in real world.